Welcome to today's webcast, everybody. We are joined by Matt here, and we are about to get started. You are going to be showing off a tool that you are very, very excited about. I think you're pretty serious about it. If I'm correct, right? Pretty serious tool.
Just a
So,
little.
yeah, I want to make sure that you have enough time to go through and talk about your tool and everything. And when there's about 5 or so minutes left, we'll jump back on and answer any questions that you all have. So I'll go ahead and head to the backstage myself and let you get started. Good luck and have fun.
Absolutely. Thanks so much, Zach.
Hey, everybody.
Alrighty, everyone. Let's jump in. So I've got a bit of a show for you today, hopefully. Either way, it's going to be a show. Either all of my demos work or all of them fail, but we're going to have fun one way or the other, right? I did blow up the tool before this and reset everything, which means that I have no idea if anything is going to work. The one run through that I went through before, let's just say it wasn't ideal, but everything ought to be fixed. Hopefully, we can show off some cool stuff here. In any case, it's my absolute pleasure to be able to have the conversation with you all today. I do have the chat right up in front of me here, so if you've got questions as we go through the conversation, please just don't hesitate to throw those questions in. I find that making this as interactive as possible is just going to make for the best experience. So please don't hesitate to do so. Without further ado, though, let's go ahead and dive right in. A quick thing about myself. Let's see if the slides work. They do work. Fantastic. I run a company called Open Security. We do types of penetration testing, incident response, vulnerability assessment, all of the jazz, very similar to how Black Hills works. In fact, I used to work at Black Hills once upon a time. And, once you join the cult, you never do leave. So I do still consider myself part of the BHAS family. But in any case, I do run a cybersecurity company that does that type of work at the moment. And I used to work with the US Air Force in the past, a little bit of work with the NSA as well. But in any case, let's actually dive into the kind of topic area that we're going to focus on, which is not just Sirius Scan, the tool, but really also the objective around scanning and why that matters so much. From the perspective of organizations that maybe don't necessarily have access to a scanner, as well as engineers who maybe want to use these kind of things too. So let's go ahead and start off with a statistic because I do love myself some stats. So, according to the Rapid7 2024 Attack Intelligence Report, that's just last year, in 2023, for the second time in 3 years, we see more mass compromise events that are arising from zero-day or very recent vulnerabilities, 53% or so, than from vulnerabilities that are known and have been exploited in the wild for a significant period of time. Now, this is a startling trend because it's rather different from what our expectations tend to be in information security. I know if you were here for the pre-show banter, one of the things that Brian mentioned is, I've been out of the game for a little while, but I've done this for 5 years. It's got to be the same, right? Oh, wait, it's not. And the thing is, within cybersecurity, everything is constantly changing. And so one of the things that we might need to recognize is that where in the past, oftentimes mass compromise events or exploits are not necessarily based off of zero-day or new techniques. They're often just based off of doing the same thing with against misconfigured environments. Today, we're actually starting to begin to experience a reverse trend. Now, that doesn't necessarily mean the end all or be all, but what we really can take away from this at first blush is that the exploitation window itself is shrinking. So one of the things that I mentioned is that I do a fair amount of incident response for certain organizations that might be breached. In fact, last week we had an incident response that was a very, very unique situation. We, in fact, found a zero-day in the middle of the incident response. We're like, oh, this is what the attacker did. So these kind of things do happen all the time. But a more poignant story to this specific statistic is that we were doing a different incident response in February. And effectively what happened is a vulnerability was added to the CISA, the Cybersecurity Infrastructure Security Agency's KEV list. That's the known exploited vulnerabilities list. Effectively what CISA does is they collect a bundle of vulnerabilities and look to see if those vulnerabilities are perhaps being exploited in the wild in order to identify or provide information, vulnerability intelligence is what we might call this, that would help you identify which vulnerabilities matter the most. Because for example, on any given year, there might be something like 30 to 40,000 unique CVE identifiers that are issued by NIST. Not all of them relate to an actual vulnerability that ends up with a finalized CVE, but many of these numbers are still built. The big point is we're talking tens of thousands of vulnerabilities per annum. There is no attacker on the planet that is trying to incorporate tens of thousands of new techniques into their TTPs, their tactics, techniques, and procedures. So the real question is not, are we vulnerable? Or are there new vulnerabilities coming about? The real question is which vulnerabilities matter the most and how do we action them and how do we discover them in a short period of time within our environment to prevent this kind of exploitation? So going back to that story, this was an organization that did get breached. And effectively, this vulnerability that was used against them, at least according to our understanding, came on the CISA KV list on the 18th of February, and they reached out to us because they were getting ransomware on the 3rd of March. Now, that doesn't necessarily mean that this is a zero-day vulnerability. It's not. But what we see from that as an example is that we've got standardized vulnerabilities that are known, perhaps, but the window that an adversary uses to get access and then exploit that, deliver their effects, maybe it's ransomware, maybe it's just straight up extortion. Both are common. And another thing that's kind of unknown in the information security community, or rather is not something that we really recognize as well, is that today we're seeing more extortion only malware and attacks than we're seeing extortion plus ransomware, which again is just a bit of a misnomer in our expectations around these kinds of breaches. And so in this specific case, it was a ransomware attack, but it's a ransomware attack that hit an organization against a known, potentially known vulnerability within a couple weeks of that vulnerability getting added to the KV list. Now, had they scanned their environment, the scanner would have easily found it. In fact, this was a vulnerability for Sonic Wall Firewall, so it was exposed directly to the internet, and it was remote code execution. So very, very bad in this situation. A standard vulnerability scanner can absolutely help out with finding those vulnerabilities, especially on a quick basis, so that you have the opportunity to respond and remediate them before an adversary gets there. But unfortunately, in this case, this is a rather large organization, but they didn't have an internal vulnerability scanner product. Because effectively, right now, there are three main ones. There is Rapid7's Nexpose scanner, there is Tenable's Nessus, and then there is Qualys's Qualys. You either have one of those three or you are praying. And for a lot of organizations, this just isn't ideal because if you've got something like a point-in-time cybersecurity assessment, like a penetration test, guess what? That tells you what's going on today, but that isn't going to tell you 2 weeks ahead of you getting ransomware that a brand new vulnerability just came out. And so one of the things that we are really experiencing on the open security side as like security testers is that we want to leave our client environments the opportunity to not just be secure, but also to keep themselves reasonably secure until the next time we show up to find more nuanced vulnerabilities within the environment. Unfortunately, if we're providing the scanning capability, that might just not be something that they have the ability to touch in general. And this was actually the direct reason for creating Sirius Scan in the first place. I see in the chat here somebody mentioned OpenVOS. What? No, OpenVOS. I don't know if that was actually said in jest, but absolutely, I think you're actually onto something here. Because open source is absolutely an answer to a certain degree when it comes to finding out about these baseline levels of resiliency inside of environments and making sure that we're not just leaving ourselves rabidly open to compromise. Unfortunately, if you've used OpenVOS recently, and OpenVOS these days is often referred to as Greenbone. There's sort of a split there, but they are effectively the same product. It struggles. It's not only just slow, though there is a lot of rewriting that's being done on that tool at the moment. They're rewriting certain components of it in Rust. Most of that is not live yet. But the point is, if you've used OpenVOS recently, you've likely experienced a fair amount of pain around that. And interestingly enough, when we talk about pain, guess what? If we're looking at organizations who maybe don't have cybersecurity experts to the top degree, troubleshooting a Linux tool like OpenVOS and figuring out the problems that are going on with your installation and getting that all up and running and then having a UI that doesn't work out pretty well is a really straightforward path to giving up. And so my biggest problem with OpenVOS right now is some of that. Somebody mentioned Rust drink. That is true. If this is a drinking game, we are definitely a shot deep. Somebody also mentioned Wiz. I think Wiz is a really, really good tool. And something like Sirius Scan, which we'll be talking about today, doesn't necessarily compete with Wiz because we are talking more about general purpose vulnerability scanning as opposed to application specific. Now, that isn't to say that application specific vulnerability scanning doesn't matter, but if we're thinking about it from a bare bones baseline perspective, you kind of start with a general purpose and then you start adding applications on top. Somebody also mentioned Nuclei. Nuclei is a great transition point into that, and we're going to talk about that here. Okay, so what is the problem with penetration testing in 2025? I think it's really important to recognize that when we're looking at something like a vulnerability scanner, that a vulnerability scanner isn't just for vulnerability assessment or vulnerability management. And we have this misnomer, I think, in the information security community, because if you look at the primary tools, Rapid7, Nessus, essentially, they don't really give you a lot of ability to then connect into those vulnerabilities, do deep inspection, remove, say, false positives. These are more like set and forget style tools in a lot of fashions where you run a scan. Maybe we've got scheduled scans. Maybe there's some configuration that's going on with this, but we effectively run the scanner and we trust the scanner to produce results that we can then action within the environment. For a lot of organizations, pen test firms specifically, and I've spoken to a lot of folks at Black Hills about this, at Open Security, we're seeing the exact same kind of thing. Many pen testers today are actually a little bit more interested in something like Nuclei than we are in our traditional scanners like, Tenable's Nest's product, because they give us a lot more control and a lot more insight, particularly in a very quick turn fashion, to find vulnerabilities. For example, I put a one in the chat here if you're familiar with the brand new Next.js vulnerability that came out about a month and a half ago. Anyone familiar with that vulnerability? I see a zero. I see a bunch of ones. Absolutely. So effectively, this is a vulnerability in a web application. Now, where do you create a scanning module to identify that? Do you create it in something like Nessus and Tenable, or let's say Qualys? Absolutely, you could do that. But these scanners are often based off of some kind of scripting language, like the Nessus attack scripting language Nazzle, and they don't necessarily make it very easy to get direct contribution super duper fast in a more simplistic fashion. For example, if you wanted to create a new custom vulnerability detection script for your vulnerability scanner, maybe it's Nessus, how do you go about doing that? Like, let's say we found a brand new 0-day in the environment we're testing, and this environment is 10,000 systems large. So we want to create a customized script to find out where else the vulnerability that we know exists happens to be around the environment. Our current tooling in the vulnerability assessment space is really designed to be very hands-off in nature. This means from like a tactical operations perspective, we can't dive into the tool and then force it to work around vulnerabilities the way that we want to. Somebody mentioned that Nazzle sucks. Nazzle is a pain in the rear to work with. You're absolutely right there. So in my opinion, one of the biggest problems that we have in the penetration testing space is that we are using tools that are not vulnerability centric in nature. In fact, I think from a penetration testing perspective, we've said, hey, look, these baseline utilities aren't good enough for us, and we're not wrong about that. But then we take the next step and we say, hey, look, here's all of these red team tools. That's the best that we've got. And so I do see a lot of penetration testers today using things like Cobalt Strike as their primary command and control mechanism. But Cobalt Strike literally doesn't even understand what a vulnerability is. From a red teaming perspective, that's not necessarily a problem. But if penetration testing is all about identifying what the art of the possible is in an exploitation context, then we really do care about vulnerabilities. Maybe not baseline vulnerabilities that just get spat out of a scanner with a pre-computated CVSS score, but we do care fundamentally about vulnerabilities, especially if we can control our journey in both discovering them and then doing operations within vulnerabilities. And ironically, I think that the big problem here, the big disconnect on the pen test side is Metasploit. Put a one in the chat if you love Metasploit. Actually, you know what? Let me abridge that. Put a one in the chat if you love Metasploit in 2025. That's a much deeper question. Because you see, one of the things that's really happening with a lot of penetration, 0.5, I love it. I see a 0 and a 0.5. Yikes. Metasploit haters in the chat. I see how it is. I love myself some Metasploit. Don't get me wrong. But I do think that Metasploit has maybe led us a little astray. Because if you think about Metasploit itself, it is a fundamentally vulnerability first focused program. Because it's trying to say, hey, look, let's understand the vulnerabilities and then let's exploit them to get code execution because hackers gotta hack. Unfortunately, in the case of Metasploit, though, because it's so focused on the exploit, the fact that vulnerability understanding, vulnerability intelligence empowers the exploitation opportunity doesn't necessarily give us that fundamental feedback mechanism at the end, which is to say, if Metasploit isn't giving us shells, we take that tool and we turn it off, we put it on the shelf, we don't look at it again. And that's really unfortunate. Now, I have seen a lot of folks who do maybe use the Metasploit database when they're doing penetration tests, but effectively what we're trying to do there is we're trying to hack vulnerability consensus into our penetration testing tooling in a way that doesn't necessarily align as well as it ought to. I fundamentally believe that the gap that we see on the pen test side is that we're missing a specific kind of tooling that cares and fundamentally focuses on vulnerabilities. Say, for example, that we have a bunch of vulnerabilities in a database for our environment, and we want to search and we want to query against those, against specific object properties. Well, in Metasploit, technically, with its Postgres database, you can do this, but there are very few other tools there that allow for that kind of interaction and that allow for you to have customized capabilities around it. Using a keyboard is not real hacking. You're right. You have to flip those bits with magnetic tweezers. In fact, funny story, if you don't have elliptical curve cryptography on your voting systems, Cosmic rays from space may very well flip a bit, and that's the real way to code. We all know this. If you're using an IDE, like maybe Cursor or something like that, you're absolutely a failure. If you're not flipping those bits manually, you ain't really hacking. So let's go ahead and dive into Sirius Scan here real quickly. We'll talk a bit about the evolution of the tool over time, and then we're just going to dive straight into demonstration because most of my presentation for you all today is really more about showing as opposed to telling. So first off, Sirius, where did it come from? We're technically on the third version of Sirius Scan at the moment. And if you look at the older versions, you'll notice that these are maybe a little bit janky and certainly have a fair amount of room for improvement. The original version of Sirius was actually oh man, I don't even know what it's called. So Docker, it's not Docker. Discord is actually written in a UI framework for custom local UIs. And the first version of Sirius was actually written in the exact same ecosystem of tooling. That was a mistake. Electron, thank you so much, Badger. That's exactly what it is. Yes, the first version of Sirius was written in Electron, and that was an absolute nightmare from a security perspective, top to bottom. Everything was a bad idea. So we moved on from that into a more of an application-focused system that's built around Docker, and that was the alpha version of Sirius, which you see here in the animated picture that's in front. Now, effectively, all of the code base from version 1 and version 2, it's gonzos now. It was absolutely crap. Somebody asked here about Vim. Why have you never learned to quit it? Look, man, Vim is the best. Vim is my religion, and every single solution that I've got out here most assuredly has Vim key bindings. If you think I'm using the up and down arrows, then you don't know about J, K, H, and L. I'm a big Vim fanboy, I will tell you. And you're right, I use Vim, by the way. Version 3 of Sirius Scan is what you see here on the screen. As you can see, it is a complete overhaul of the tool. And I'd love to dive into some of the details about that and help, kind of spread a little bit of light on exactly how the different components work. Effectively, the Sirius Scan project has been a passion project of mine that's been going on for about the last 5 years now. And essentially, as of October of last year, so effectively Wild West Hack Fest, we got to a stage where the tool just kind of worked, which is to say all the bits and pieces that are there that are necessary in order to make something like this happen were in place. And so over the last year, there's been a huge level of improvement across different components of the tool. And actually, I've got a specialized version for you that's not quite public just yet that I'd love to show off and some of the capability sets within it. First off, the architecture of Sirius Scan. It's all built around Docker containers, and it is entirely modular in nature. What that effectively means is if you look at the UI here and you hate it, you don't have to live with it, because effectively all that this UI does is it communicates with the API server in order to get, represent data, and then also give you controls in order to take actions with the environment. So if you wanted to just grab the UI, throw that away, put a different UI right in front of it, all you've got to do is make the same connections. And effectively, the entire ecosystem is built that way. There's actually an SDK written in Golang that could allow you to completely re-implement the API if you wanted to. The API here is basically just the SDK implemented. And so if you wanted to do this in a different fashion, or if there's a specific component of the tool that you don't like, they're all made to be, pull outable and replaceable individually. This means that if we find that we maybe made a bad choice in the UI design, which I absolutely did with version 1 and to a certain extent version 2 of the tool, we can rip that out while still maintaining all of the underlying ecosystem of the tool itself. And we continue to develop and build upon that, which is really, really handy. Is the UI Kibana? It is not. The UI is fully custom JavaScript, TypeScript, and well, actually, it's mostly TypeScript, not JavaScript, but it's Next.js, fully custom. In fact, though, I do want to bring up Kibana, because one of the things that is really handy with Kibana, and if folks aren't familiar, Kibana is effectively the UI component of the Elk stack of software. And so it's very frequently used by security operations centers as part of maybe their SIM as well. And what it's really powerful at is being able to search through data. This is something that we had to kind of design from a Sirius perspective in order to make the tool also capable of doing the same things. But one of the expectations that I do have, if you were to use maybe this tool against an organization environment with over 10,000 systems, is I would expect the search capability to be reasonably slow, maybe. I haven't quite tested it against that yet, so we'll have to see if that's true. But the reason for it is because certain systems are designed for search specifically. That's going to be a long-term upgrade to Sirius Scan in general, but I do love how you brought up Kibana, because there is a reason why folks design design UIs in Kibana, and in many cases, it's for performance. Now, if we think about Sirius Scan itself, part of the reason for its architecture here is to allow for lateral scalability. Note that every one of the different boxes you see up here, they're all individual containers, which means that these containers can be run anywhere. One of the things I'm working on with Sirius Scan at the moment is actually Terraform scripts for you to be able to automatically, in one button, spin up a full Sirius Scan environment in the cloud so that you can then start scanning things. Drink, I didn't say Rust. What are you talking about? And that's the objective there, which means that if we're talking about a much larger organization or environment, you can natively start to scale laterally because each of your engines can actually be duplicated. Now, I would not necessarily recommend trying to do that right now, but that is actually the purpose behind the design of the tool itself. If you were to try to do multiple engines right now, I imagine you would find bugs because I haven't tested it very well. But the design of the tool itself is to allow for long-term lateral scalability so that we don't end up with something that is slow and can't keep up with our emerging requirements, because cybersecurity is different every single day when we wake up. Natively scale laterally. That's what you do when you eat chocolate. That is a good one. Not gonna lie. All right, so the Sirius project itself, it's all open source, it's MIT licensed, and it is on GitHub. Now, it is actually a confluence of multiple different projects simultaneously. So you'll notice here there's 13 different repositories that are part of the tool at the moment. And each one of its subcomponents, like the agent, for example, or maybe the SDK, the terminal, the scanner, they're all sub-projects. It's designed like this because I wanted to make Sirius Scan as easy to contribute to as possible. That means that if you wanted to create a brand new scanner, all you'd have to do is create a sub project as a module that can just get slapped onto the tool and will work within the engine on its own. The SDK specifically provides functions that you could use for something like that in order to connect it to the database and to the API as well. So that would keep you, if you wanted to develop in the space, it would keep you working within the specific area of the code that you're trying to create, not dealing with all the hamstring parts of the tool itself, which is rather, I think it's useful. Certainly from my perspective, if I'm trying to add new scanning modules and I'm trying to do that really, really quickly, the fact that many of these things are just imported capabilities does make it much more possible to start to create things really, really fast and to iterate in that type of cycle. Yeah, let's actually talk about some of the details here with the scan. And in fact, before we jump into like just details on the scan, let's go ahead and run ourselves one. And so this is where all of the chickens that I have hopefully murdered properly are going to align, I think. Either my demo completely doesn't work and we're in trouble, or it does. If logging in with a password literally didn't work, then we were really in trouble. But fortunately, that one was just a typo. Okay, so here's the Sirius Scan dashboard with no information attached to it. The first thing that I want to do here is I want to talk a little bit about what it takes to build a vulnerability scanner and what features need to be there versus which ones are more extraneous and not necessarily required for MVP. So in this case, you see the dashboard. That makes a lot of sense. You can't really have a tool without a dashboard. But effectively, if we're looking at a scanner, there's basically 4 different components, 3 to 4 that you really need to have. Specifically, you need to have something that can do your scans. Secondarily, after you've performed some scans, you need to be able to look at your environment and see all of the vulnerabilities that affect your environment as a whole. So a scanner, a environment view, and then next, you also want to be able to look at the hosts that have been discovered and be able to interact with those. These are the primary features that you would need in a vulnerability scanner. And so if you look at this from a sub-page perspective, the 2 extra pages that you might add on top of that are something like a vulnerability view, so we can inspect an individual vulnerability in more depth, and also a host view, so that we really get some good insight on our host itself. Sirius has one extra component on top of that, and that is the engine, which allows you to get a full command line and scripting interface. A lot of the stuff in the engine side is very new. I can't wait to show it off. So far, so good on the demo side, but let's actually start off by just giving ourselves the opportunity to run a scan. In this case, I'm just going to pick, I'm going to pick an IP address here that I have up and running. I'll start off a scan on that, and I'm actually going to run a quick scan here. We'll let that run in the background, and as that's going, let's jump back to the slides and kind of talk through scanning provenance within the tool. So for most vulnerability scanners, scanning provenance isn't an issue. And the reason for that is if you're Rapid7 and you run a Rapid7 scan, guess what? It's your scan in your tool. And so if you want to put the data in the database as a result of that, you just do it. But Sirius is actually designed to be a scanner of scanners. This means that it's running scans with Nmap scripting engine. It's running scans potentially with Nabu from Product Discovery, with its agent, with Nuclei in the future. The agent has multiple different ways to detect vulnerabilities on side of local systems that it has been installed on. All of these different things might overlap or overwrite each other if we don't actually have good detection around scan source. It is rather uncommon to see a vulnerability scanner that has that capability because, again, traditionally with a vulnerability scanner, it's its own source and it only has the one. But if we look at, say, vulnerability data management utilities, like let's say Defect Dojo by OWASP or Brinka, or maybe ServiceNow's vulnerability management module, in those situations, because they recognize that they're putting data together from multiple different sources, they're actually tracking the discovered source in the first place so that they don't overlap each other as far as information is concerned. And we'll be able to see a little bit of that here with our first scan. So here we ran a scan with Nabu, which is a very, very quick scan. And this is just a port scan. If I then click on the system that we scanned, what you'll notice here is that we do get our port scan results. And this is the host view inside of Sirius. You'll also notice that there's just not a lot of information here whatsoever. And the reason for that is because we ran a very basic port scan using the Nabu tool. And we can actually see here that it is very specifically specifying what tool was able to create the data that we're leveraging here and what we're using for analysis. This is particularly useful because in a given engagement, it is rather possible that something like Nabu or RustScan is just not working for whatever reason. And if we're getting a lot of false positives from one tool, knowing the provenance of our vulnerability scanning results can help us filter that information out so that we're not spending a lot of time dealing with false positives that we don't necessarily want to. Hey, I did say Rust, but I said RustScan. Okay, that's one word. That doesn't count. Let's see here. I know there are a bundle of questions that came in. Let me check the questions here real quick. Speed is life. So one of the things that's rather interesting about Sirius Scan at the moment is that it is super fast. However, I'm pretty sure that a lot of that speed has to do with what it is itself doing. And I do expect to have a fair amount of performance improvements that I'll have to work on the tool for the next 6 months. Let me start with the ends in mind here, in fact. So where is the tool at? How's it working now? What does it look like? In my opinion, it's a mess, but that's because I'm the developer of it and I cannot be happy about anything. But the objective is to have the tool in a pretty stable beta fashion for Hacker Summer Camps. So that'll be in about 3 weeks. After that, the beta should run until the end of the year. And the objective as far as delivery of Sirius Scan is to actually have a 1.0 version by Christmas of this year. And that version should be rather stable. There shouldn't be standard problems. I know somebody in the chat was mentioning that they were having a lot of trouble with getting it running in Kali Linux. Guess what? That is absolutely an operating system that I want to support by default. But I'm not necessarily testing every single operating system for every different update that we do to the tool just yet. But the objective is to absolutely spend the next 6 months getting that level of stability and robustness built into the tool itself. Because at this point, we're actually getting very close to having all the prime features that are required in order to have a really solid scanner. And so the question is not, do these features exist, but do they work, and do they work well, or is it more pain than it's worth? And that is absolutely what the primary objective is that I'm working towards with the tool at the moment. Okay, so let's go ahead and continue with Sirius Scan. And let's actually run ourselves a more in-depth scan right here. So I'm going to pick another system within my environment right here. And this one happens to be rather vulnerable. We'll go ahead and trigger this, and I'm going to do a full scan of this. Now, while that scan is running, let's go ahead and talk through how Sirius scans work in general. At the moment, there are 3 general styles of scans, and you have to run them individually in the right way every time. The reason for this is specifically development related, because I don't want to have cascading bugs that I have a lot of trouble, troubleshooting. But in the future, the objective should be that from the scanning interface, if you hit start scan, it should do a network scan. And if an agent already exists on that system, it should also do an agent scan. At the moment, you have to trigger these scans separately, but once this tool moves into a bit more of a robust beta sense, and absolutely once it gets into version 1.0, all of these scans will be part of your configuration that you can actually control from a template perspective. So you can say, hey, look, I don't want you to do an agent scan. I do want you to do a network scan, or vice versa. And so the question that you might ask yourself is, why? If we already have an agent in play, shouldn't the agent be able to find all of the significant vulnerabilities on its own? Aren't agent scans superior to unauthenticated scans? And this is a very common misnomer that I see all the time. It's a question that penetration testers, generally speaking, don't struggle with, but vulnerability assessors and vulnerability management teams often do, because they tend to look at these types of scans as if one is a superset versus the other. And that's just not true. So being able to control what tools are being leveraged to perform a scan is exceptionally valuable here. And in this case, the scan ran against this Windows system, and it found 16 vulnerabilities. So if we open this sucker up, what we'll see here is a much more significant set of information about the findings related to this device directly. You can see a bit of an overview of things like packages. You'll notice that almost all of this information is empty. That's because the agent can actually fill in that information, but a remote network scan might not be able to get that insight. If we go to system information, there's also the ability to look at user accounts. Again, that's information that a network scan is likely just not going to be able to achieve. And so if we're doing an agent-based scan on top of that, we're going to get vulnerabilities on the network side. We're going to get maybe local system vulnerabilities and SBOM scanning. We'll even get things like the software inventory in place. But when you put all of these different perspectives in conjunction to each other, you get much more insight on the local system. If we're thinking about this again from a penetration testing perspective, we're actually seeing a lot of things that are quite actionable here. First off, I love to start with ports because ports tell me what the attack surface is and what the art of the possible might be. If we then dive into the vulnerabilities here, you'll see that there are a number of these that are rather interesting. There's actually a critical vulnerability here for the Nginx server. And a very interesting vulnerability is, if I can find it, let me filter appropriately. There we go. Is this one right here, CV 2017-0143. Does anyone know what that happens to be? Post in the chat if you're familiar with this vulnerability. This one's a big one. Eternal blue. Yes, you're 100% right. So if we click on the individual vulnerability, this will actually take us to the vulnerability page. Oh no, I'm gonna get my first demo fail. No, I think it's working. Allegedly. One note, if you're noticing that when I click on a link, it takes a little while to load, that's actually because I have this running in a development server at the moment. So it actually has to recompile the page before every different browse. In the prod version, the entire Next.js front-end application is built. And so the navigation does tend to be a lot snappier. One of the things you might notice here is that if I navigate back to where I came from, that page is already pre-compiled, and you'll notice how much faster that navigation actually happens. Again, that's effectively just because I'm running this in development mode right now. And so if you're doing this in a production perspective, that slowness that you might be perceiving here doesn't actually replicate over. Let me find that vulnerability again. That's not the one I was looking for. One more time. There we go. Cool. And so this here is a page on the vulnerability itself. Oh, so I test in production too. I think that that's probably fair. As the developer of the tool, you tested like all variants possible at the same time. But yeah, sure. You're definitely not wrong. Let's see here. Learned it on Try Hack Me. Yeah, so if we look at the actual vulnerability here, you'll notice that you get some information about, like, say, the CIA triad. We can get CPE information here. I probably should open this in another tab, and these will link to places like NIST. We can also get other information about the individual vulnerabilities there, particularly useful. One thing you'll notice here, as far as an update that the tool needs that it doesn't necessarily have just yet, is that it should also be able to tell you what systems within your entire environment are affected by this vulnerability. You notice that I have mock data in place here, and that's because that's not necessarily a feature that I've already completed, but that is one example of how the tool is progressing and one of the edge situations that will be very valuable once they're done, that are still being kind of worked on. Most of these types of features, though, are rather quick and easy to create because we've effectively gone from this ecosystem where everything needs to be baseline built in order for us to layer capability on top. At this point, 5 years in, we're at that level where the backend capability does exist. And now the question becomes, what features do we want to layer on top, and what is going to be the maximal value proposition for the folks who are using it? Alrighty, let's see, where was I? Okay, so we talked a little bit about why multiple scanners here, and we ran ourselves a network scan. Let's actually go ahead and go a little bit deeper here and start looking for individual vulnerabilities on given systems. Now, this is where my demos really might start to fail. Let's start by going towards the engine itself, or sorry, the agent itself, and let's see if we can get an agent to run. Okay. we go. Let me pull this over so you can kind of see what's actually, let's do this on the Windows side because I do have this set up for you as well. So here I've got remote desktop going on a Windows system. The way the engine itself, not the engine, the agent itself works. Okay, I should not have hit the magnifier. It was a mistake. Does it count as a demo fail if you just can't use your computer properly? Here, let me pull this aside so I can actually get to the start bar. Okay. So when you run the agent, effectively, there's two things that happen here. First off, you need to tell it what the server is. These are all done through environment variables. So if you set up the environment variables like this, you can then have it connect back into the remote system by just running the agent itself. And so theoretically, if this works, what we should see is in Sirius Scan here on the left-hand side, some agents connecting back in. It does, there we go. It does take it a little while for those agents to connect because effectively they're doing a bit of a heartbeat challenge and response here. And so I started up 3 agents. You see 2 of them that I started up a little bit earlier. But what you'll notice here is the Windows one is still kind of starting up, allegedly. And we'll give that a little bit of time to work. But effectively, what we've got here now is we have some kind of terminal itself. And we can use this in order to interact with all of the different systems that have been connected into or that are associated with the ecosystem. Now, if this feels a little bit like a command and control tool, it is. And fundamentally, I believe that a vulnerability scanner should allow you to take action related to vulnerabilities on the systems and in the places within your environment. I think that that's really, really important. And so starting off with something like a C2, well, that's probably me just having too much red team in my heart and not being able to let it go. But at the same time, this is super duper powerful. The engine on the Sirius side, you can see here that the Windows agent just connected in, but the engine on the Sirius side is also fully built in PowerShell. Now, the engine itself is on Linux. We're using PowerShell.NET Core here, but effectively what that means is that you can use PowerShell on the engine side to then script things to your heart's content. A lot of those features I'm actually still working on and aren't necessarily fully built in just yet. But here's an example of one of the things that you might be able to do with the agents in honestly the next 3 weeks. This is very, very close to being done. But let's say that we use the get agents commandlet. Again, this commandlet not done yet, so this won't work. But the idea might be, let's say we do get agents, and this gives us back as an object within PowerShell all 3 of these agents. We could then say something like for each object, which is % inside of PowerShell, a little bit like you see here. And then we could do something for each one of the agents. And we might do something like, say, dump hashes like this. And then we might pipe this out of that and then have like a specific hash that we're looking for. Now, let's say that we have identified within our environment a password or a user account that is being exploited or that is bad or is just insecure. It's a bad password, maybe. More importantly, our question becomes, does this credential exist elsewhere within the environment? Theoretically, if we have an agent on all of these systems, what we can just do is we can just, in a real quick PowerShell one-liner, say, get all of the local hashes from all of the systems, and then look with, let's say, select string here. I didn't actually do select string. Look with select string in order to find any of those specific hashes that match in this case. This is the kind of scripting capability that really is, I think, vital to do hardcore rapid tactical operations from a penetration testing perspective. Note again that this did error, and that's because both the get agents commandlet and the dump hashes commandlet don't live on the engine just yet, but this is very, very soon going to happen. Effectively, what I'm getting at is the objective of the engine here is to be able to take your vulnerability data and make it actionable and scriptable within your environment so that you don't ever have to repeat yourself or do the same thing twice. This is the Sirius engine. If I want to interact with the individual agents, I could actually do agents like this. Oops, with an S. My apologies. And there's also the ability to interact with them from the command line. The command line here also has tab completion. So if I said something like agents, I could hit double tab. Okay, that's definitely a demo fail. Oh, it's use. It's not a demo fail. I just don't know how to use my own tool. It's very similar to the Metasploit kind of command syntax. So I could say something like use agent, and then I could specify the individual agent, and all of this is tab completable. In addition to that, if I didn't want to do it from the command line, I can actually just click in each one of these, and it will let me switch the context of my agent to whatever system it is that I want to work on. Now, one of the things that I mentioned is that the way Sirius Scan works at the moment is that you have to manually trigger every type of scan that you want to do. In the future, what should happen is that when an agent gets installed on a system, that should automatically trigger a scan, and that scan should report to Sirius all of the details. Right now, there's an extra step, and effectively, all it requires you to do is connect to an agent and then click the scan button or type scan, and it will fail. It will fail. Great. Oh no. Oh, it worked the second time. Alrighty, there we go. So in this case, I ran a scan against the system. I don't know why it failed. Let's not question it. Okay, it worked the third time we tried it. Third time's a charm. Don't ask no questions. I'm gonna have to do a little bit of research there for sure. Um, oh, I reset that, didn't I? I created a new vulnerability on that system in order to get an extra detection, but I haven't sent that back. So let me fix that for us real quick here. Okay, let me try that scan one more time because it should actually give us a detection, and it does. So in the case of the agent, there's basically three general ways where the agent performs a scan. Now, what you might have noticed here is that it gives you this big laundry list of information. That's effectively the software inventory that is pulled back from the remote system. And so if I go back to the environment view here, what you'll notice is that this engine now has results on it, and those results include a vulnerability. If I click on it, it'll take me to that host view. And what you'll be able to see is all those software packages. We get to see all of the user accounts, all of this information that's really valuable from a penetration testing perspective. But from a pen test perspective, we almost always end up running the same commands over and over again on all the systems that we gain access to. If I go back to like my NSA days, we might call this a site survey, kind of getting a good understanding of what is happening on that system, what's going on with that device, what the attack surface might look like, what ports are open, what user accounts are in place, what groups are there, who's in those groups, et cetera, et cetera, et cetera. In this case, the agent, as part of its scan, automatically collects all of that data back. And so instead of having to run, myriad different commands in order to retrieve this information, we can actually just run the scan command, then go into the actual system and take a look. Note here, I'm going to take a look at the vulnerabilities here real quick first. This vulnerability that it has discovered is labeled test 2024-001. What is this? So effectively, the way that the agent works is that it has a number of different ways to detect vulnerabilities. If I go to system information here, there's a software inventory, and it pulls back all of the software information. One of the things that the tool is not very good at right now is that it should be taking that software information and turn them into something called common platform enumeration, which looks a little bit like this, as you see on your screen here. The idea there is we can create basically a software tag for a given application and then look it up in a vulnerability database to see if that version of the software has vulnerabilities associated with it. This is the primary mechanism that most vulnerability scanners use in order to find the vast majority of vulnerabilities in the environment. It is also one that is exceptionally prone to false positives. So there are pros and cons to this approach. And this is one of the reasons why knowing the provenance of the vulnerability, as in what was the thing that did the detection in the first place, can be really, really useful. Because if we're finding that one specific mechanism is highly prone to false positives, guess what? Maybe we want to filter that one out so that we can spend our time in the most, optimal fashion as possible. Now, of course, it's an agent, which means that it's going to give you a lot more information about the ecosystem itself, too. We could look at user accounts, for example. And here we'll see that on the engine for Sirius Scan, which I ran one of these agents, there's a bunch of groups here, and there's also one user account. I'm going to run another scan here, but I'm going to run a scan against the Windows device because there's actually a lot more information to see on that device than just a Docker container like they used for the first one. This is where I really have to cross my fingers because I totally broke the Windows agent earlier today. I think I fixed it, but I'm not exceptionally confident. So let's see if this works out for us. Yes, fingers crossed for certain. The Windows scan does take a significant amount of additional time. Let me talk about how the scans work in general so you can get a good understanding of what they're doing. So effectively, if you're on like a Mac device or a Linux device, it's interacting with your package manager in order to pull down all of the different pieces of software and the versions that are installed in your local system. In the case of Windows, you may have package managers like, let's say, Chocolatey, but those are generally speaking not native components of the operating system. And so if we're doing service bill of materials scanning, that is typically done on the Windows side through the Windows registry. Effectively, that does mean that this scan tends to take a fair amount of time. Here it told us that the command effectively timed out, but I think it worked. Let's see if it worked. It did. Absolutely. Doesn't look good. Ain't pretty, but it did work. So effectively what happened there is that Windows scans do take a significant amount longer. And so the UI didn't wait long enough in order to show us those results. This is actually a bug that I'm well aware of and that I do need to fix. Effectively, the Windows system that we just scanned is in a virtual machine, and that virtual machine doesn't have a huge amount of resources. So the scan does take a bit of time to complete, and the terminal doesn't know when that scan actually completed. So what you're effectively seeing here is that the terminal had a little bit of bugs, but we do get the data that we're looking for. So let's take a look at the information that we're able to receive from this device. If you notice here, we get information about vulnerabilities, and we also are going to get information about the user account specifically here. Oh, no, we don't. Oh, here I am saying it worked, and it totally did not work. Fail. I knew this was going to fail. Unfortunate. I'll use my my Mac instead, actually, because the scan does run much faster. Allegedly. Domain domination via compromise of the vulnerability management system is a question in the chat. I think this is really important to be aware of. I do not currently recommend that you use Sirius Scan and implant all of your devices with an agent and leave those there long term. Are there potential attack surface about like impersonating the server and then taking over the agent? I think so. I haven't done enough penetration testing of this tool. I'm pretty well, aware of where these vulnerabilities start to come from. But I would be very cautious with using a beta utility that has direct administrator level access to your individual systems across all of your systems simultaneously. I do believe that this security is like a primary concern of mine for the tool itself. And I do believe that all of these things are not just going to be buttoned up, but I'll have documentation to support why they are secure, because I think that's really important. But as it currently stands, I think that that's a really good question. How secure and how safe is this tool to use in your environment itself? I think if we're talking about running it as a bit of a one-off style utility where we're trying to do an engagement that's in a specific window of time and we remove it after the fact, I think that that's rather safe in this kind of implementation, because we are talking about effectively there being a potential for zero-day vulnerabilities to affect this open source piece of software. Do those exist? I certainly believe that they might. And I intend to do a lot of research to make sure that we have closed those potential loops out. But I also believe that it is really important to recognize that in the short term. And so consider running this with a firewall in place. And also the default password is password. Please do change that. If you go to settings here inside of the tool, you can change the password super duper easily. But if you leave the password as password and you use the tool to implant your entire operating system environment, your ecosystem, bad. Don't do that. But it is really easy to change the password. All you have to do is click on the security button here inside a user profile, and you can change the password super duper quick. But security is definitely something that I'm working to achieve a lot more around here in the future. Again, great question. Alrighty, so let's take a look here at our software. So what you might notice now is that we've done a number of different vulnerability scans. And here we see that my local Mac device isn't listed as having any vulnerabilities. But if we go to the scanner here, because we didn't actually do a network scan of it, and I throw in its IP address, what we're going to find is that there are certain vulnerabilities on it. And in conjunction, the network scan and the agent scan together give us a better sight picture of what the risk is going to be for that given device. So if I were to run a vulnerability scan here real quick against that system, it'll give us some of that insight. And we are coming up on time here, so I'm going to go through the slides. We've kind of been talking about most of this as we went through, so I'm just going to highlight some of the information that I haven't actually pulled specifically mentioned. So first off, we're using a bundle of different scanners within the ecosystem, things like Project Discovery Nabu, like Nmap, all of these types of things. Once you've actually got data, it's going to show you your vulnerability information. This comes originally from NIST. However, one of the things that's rather interesting here is that I actually have a full CI/CD pipeline, and I'm calling it vulnerability GPT. That's a little silly. But the idea there is actually pulling and pulling NIST to see any new CVE, and then it's using retrieval augmented generation in order to create a custom set of information around it so that you can get additional information about the vulnerability, about remediation potential, what to do about it, etc., beyond what the default NIST is, which is very similar to what you see with these commercial scanners. And I do think that artificial intelligence in the open source space does present a lot of opportunity to close the gap between open source tooling and commercial utilities as well. I think it's a really, really powerful and emerging opportunity space. Here's the agent. We've talked about this pretty at length. Common platform enumeration is a great way to get that connection in between your software inventory and the vulnerabilities associated with those different versions of software. Here's that software inventory. Let me give a demo of this here real quick. Notice here, we see that this scanner did complete, and you've got the new vulnerabilities on that Mac device. Fantastic. You can see all that stuff. But if we go to the environment view here, you can actually click on software inventory. And this will allow us to look at all of the software across every single device that the agent exists on in the entire environment. So if I'm curious to see where Notepad++ exists, oh no, this is a bug that I fixed and then I must have broken again. Every time I hit a letter, it refreshes that component of the page. I totally fixed that a couple days ago. I need to go back in and fix it again. Bigger point. Here you see Notepad++, and we can actually get the direct version of that piece of software in the environment. So if we wanted to do a little bit of vulnerability research, we could perhaps go to something like Vulners and then look up something like Notepad++. The objective of Sirius over the next, let's say 3 months, is to do this piece for you automatically. So in this case, we're doing a little bit of research on the version of the software itself, and it's telling us here's a bundle of vulnerabilities associated with it. The goal of the tool is to actually do that kind of CPE collaboration for you in an automated sense so that your software inventory is effectively empowered across the entire environment, so that if you identify, hey, look, I was exploiting this thing and it worked, where else is this? You should be able to search for that super duper easily and then move laterally into those systems if we're thinking about it from, let's say, a penetration testing perspective already. On to the research. Oh, yes. And then here's my last little section about features within the tool. On the agent side, there's not a whole lot of customization capability that you currently have access to, but that is coming really soon. On the network side, however, that customization already exists. So if you go to the advanced section here under the scan, let's say we're looking at Nmap, you can actually control the repositories where your Nmap scripting engine scans are coming from. And so one of my biggest complaints with Nmap is that it's really difficult in the open source community to contribute new scanning modules to Nmap because the Nmap product themselves control that. And so if you have a custom variant of Nmap where you can slap on repositories from anyone out there in the open source world in general, then effectively you have the ability to control your scanning repository and build upon that, and also even add on to that, which is really, really nice. In addition to this, if you want to do customized modifications to the scans that are inside of Nmap, you can actually just go to scripts here, click on any one of these, and actually open up the code editor. And in this case, I can actually see and modify the direct code base of this Nmap scripting engine script. The objective for the agent is to do this exact same thing in the future. So in the case of the agent, it actually supports both script-based detection as well as template-based scans. If anyone's familiar with Nuclei, Nuclei has really changed the world on how we do vulnerability scanning and how we can create these modules very fast. Because instead of doing scripting, they also have the ability to create templates around what a vulnerability looks like. And so in this case, we're saying, hey, look, if this file in this location has this hash, flag it as a vulnerability. That's all that this does. And so if I want to create a new detection capability, maybe it's not even a real vulnerability. Maybe it's just something I care about from a penetration testing perspective. I can absolutely create a template here real quickly, scan the entire environment for that real quick, and find out if the password.txt file, exists anywhere in the ecosystem without having to get my hands dirty and build custom PowerShell scripts or maybe Lua scripts, which is kind of the primary objective for the tool itself. Now, how would you access that capability set? The idea is that the exact same way that you can go into Nmap and configure the scan, even edit the different templates, that should work the exact same way for both Nuclei when that gets integrated in the future, as well as the agent, and the agent is almost there. All right, with that being said, I know we are right up to about the last 5 minutes here. That is kind of the last slide that I've got. The last thing to talk about here effectively is just where's the project going. I stole most of my thunder there already getting into it because I was too excited to hold off for this slide. But effectively, we do want to have some additional integration of artificial intelligence to make the application as powerful as possible, specifically when we're talking about the vulnerability database and enriching that information. I'm not saying that this is going to be an AI tool that just does everything for you. Maybe someday, but right now the objective is to use artificial intelligence in order to take an open source project and make it possible to match up with the Joneses, to be able to look like a commercial style vulnerability scanner and give reasonably equivalent results, as well as a lot more capability. Speaking of the capability, our primary objective here is going to be all around automation. So the engine improvements, scripting, there isn't a task scheduler yet that's coming down the road. So all of these improvements around automation so that you can take this data capability that Sirius provides and actually turn it into something that you can use in order to create the report that you want to make, and to do that really fast whenever performing your vulnerability assessments or penetration tests, be it for a third-party organization, your own home, or for the organization that you work within on a day-to-day basis. In any case, that has been not quite all of my time, but that is my slides. So I'm going to open up here for questions. I would be more than happy to answer as many as I can.
Well, Matt, while we're waiting for the questions to roll in, I just got to say this has been a great presentation. I was glad to see that everything, at least almost everything, if not everything, did end up working for the most part for you. So apparently your chicken sacrifice was sufficient for today's task. Oh, but man, this was really cool. Yeah, I really look forward to you having that that primetime ready version of this thing coming out, because I am totally down with this. I love everything you're working on, all your plans that you have for it. Is like it was basically like you bugged my house for a Christmas list of things I would want in a vulnerability scanner and said, well, let me just do Daniel a solid real quick and build him an awesome tool. So really looking forward to that. Let's check out and see if there's anybody in the chat. I did see some Q&A over in the Zoom Q&A, which I can grab. Brian Johnson asks, where can I find the config change to allow access to port 3000 from any host on the network? I'm going to play with this on a headless system, so I can't access from localhost. And correct me if I'm wrong, it is basically doing that by default. You're just telling them to go to localhost, right? As a default mechanism.
100% right, Daniel. If you just change localhost with your IP address, it will work. In fact, let me demo that for you real quick so you can actually see it. So in this case, I've got it set to localhost, but if I replace that with just my IP address for this scanning system, you'll be able to connect to it across the network like so. Which, again, like there were a couple folks who were mentioning security things. This is not the configuration that I would recommend necessarily for a beta tool, particularly where the password is set to password by default. But you absolutely do have that capability, and I intend to make this not more secure, because I don't know for a fact that it is insecure, but I intend to be very confident about what the security state is, and this tool will come with a pen test report of itself before it gets to version 1 launch.
Oh, that's going to be awesome, right? Some baked in, like we did actually test this to see whether or not it's insecure. We do have a question. And then you'll be able to see that
my methodology is boomer style.
You say that like it's a pejorative, right? Like, what's wrong with that? As my graybeard speaks. Green Jam says, any intent to include exports from additional commercial tools in the same area?
I imagine you mean imports as opposed to exports. That's a really good question. And so imports, I haven't actually considered that from the commercial tool aspect, but imports are absolutely coming for, so here's something I didn't demonstrate. I want the agent to be fully standalone possible without the need for Sirius Scan itself. And one of the pieces of features that's coming with the CPE integration is you should be able to actually just take that agent, download it, run it on your local system, get that JSON output without needing Sirius Scan up and running at all. Then at that point, if you wanted to have like a headless version of Sirius that maybe not even connected to the network and you want to import that JSON output, you should be able to import it, and then you should be able to navigate through and deal with all of the data that's been pulled out by that scan itself. The reason why I want this is, let's say that you're using something like Cobalt Strike or Metasploit and you're like 3 hops deep. In that situation, getting like outbound connectivity to a vulnerability scanner is really nasty. But if you could just drop a binary on the system, run a scan directly like that, and then import the output of that into Sirius, awesome.
Yeah, that's money.
So that is absolutely coming. It's also coming for, say, Nmap. I have not thought about integrating, let's say, Nessus and Rapid7 output. I'm not sure if that's the right direction for the tool either, because I do want to integrate it with other open source projects. And there is an open source vulnerability data management solution by OWASP called Defect Dojo. And it does have the ability to import from things like Nessus and Rapid7. And I do think the right way for Sirius to play well with other open source projects is to work with them as opposed to overlapping them. So I'm not saying no, I'm just saying there's a lot of considerations around that we're currently working through. And in the end, the answer to everything tends to be yes, right? Because scope creep kills us all.
It does. It is the demon lurking in the background, just waiting to devour you. That said, speaking of the demon, we got 1 minute left. I got one question I think is probably a really good one for us to kick things out of Discord, and then we'll jump into the AMA in the back. What we have is a little breakout room, and I'll direct you how to get there. So if you're joining us on Zoom, we'll be going there momentarily. If you're on Discord, it was good talking with you, right? But right now, one last question is, how noisy is the scan? They say this is from Benjamin Wolf. We typically avoid automated scanners during pen tests for OPSEC reasons.
Mhm. Yeah. So I don't necessarily know if that's the best call from a penetration testing perspective, though when you're dealing with the client, all of these things are up in the air. So in my mind, the way that I like to differentiate it is if I'm doing a pen test, I don't care about getting caught. Sometimes you actually are forced to. But if I'm doing a red team, I really, really care about being silent. And so Sirius is developed specifically to support penetration testing objectives, not red team ones, which does create a little bit of an interesting dichotomy, if you will. So the scan doesn't run automatically, which does mean that there aren't any direct host survey problems that you might experience from a red team side right off the bat. But the agent does use gRPC as opposed to, let's say, an API call that includes jitter and maybe timeouts and these kind of things. This means that that agent is designed specifically to be highly available, not highly covert in nature. So I would not consider Sirius Scan to be a covert tool in any way, shape, or form. But remember, the tool is entirely built around this modular Docker container idea. So if you take the agent, delete it, and you replace it with another agent that speaks the right spec, which I didn't actually show the documentation side. I hate documentation, but I think it's really important. I spent a huge amount of time working on documentation for this. So there's actually a full documentation site on the tool that also talks about like the API reference and how you can control things, how authentication works, how the endpoints, agents, they work in general as well. So effectively what I'm getting at is if you wanted to build a super covert agent that connects to the Sirius ecosystem, but does it in a very covert style, you can absolutely just rip the agent out, replace it with your own. And I do intend to continue building more documentation to make it easier to do that kind of thing. But don't tell the antivirus vendors because I don't want to get flagged.
Good to know. Good to know. All right. Well, that is time for our anti-cast today. We are going to be now moving back into the Zoom Q&A section. For those of you that are joining us on Zoom, what you're going to look is for the breakout rooms. You click the breakout rooms right there at the bottom of your screen, and you're going to see one that says Ask Anti-Siphon Anything. You're going to want to join that room, which is where myself and Matt are going to go momentarily. For those of you in Discord, thank you so much. The memes were chef's kiss today. We appreciate all your interaction and engagement with us. And thanks for joining us. And until next time, have a great day. We're going to go to those breakout rooms.
Speaking of which.